Welcome to section 1.5, Measured Numbers and Significant Figures. Measured numbers are anything that you calculate, okay? So if you're going to measure your height, you're going to estimate or calculate your height or your weight or temperature, any kind of calculations that you do, any measurement that you take. That is a measured number. When you write a measured number, you're going to be measuring with something, whether it's a yardstick or the bathroom scales or whatever, and it'll have certain marks on it, like it'll how a ruler has different marks on it, okay? So you'll measure from one to the other. Okay, but if whatever you're measuring only falls to like right here, you may have to make an estimate right there. And so your final number in a measurement is typically an estimate. So what I'm talking about, aren't you glad we have good pictures, because you'd really be hurting if you had to rely on my drawing. The lengths of objects, if we measured here, if you look at A, okay, on A we measured right here, okay? And so the person measuring that could very reasonably estimate that to be 4.5, and that's as close as you could get to that measurement. That's as accurate as you could be. If someone used a measuring device that had more marks on it, you can see that it's actually just a little bit farther. Farther. And so you could estimate that it's farther than the 4.5, but not quite to 4.6. So you could estimate that last digit to be halfway between, just like you estimated that was halfway between the 4 and the 5. It was higher than 4, but not as high as 5. And this last one, it's right on the money, so it's an easy one. So we could say 3.0 because we were sure that it was almost exactly 3.0 centimeters. So we're having to estimate that. And so what we do is when we're writing these measurements, we write a certain number of significant figures. Significant figures is basically how accurate that measurement is. Okay? So a number in a measurement is significant if it's not a zero. Okay? If it just is a number of some type, it is significant. In this number right here, you have two significant figures. A zero that's between two numbers is significant as well. And so that number would have three significant figures. A zero at the end, if there is a decimal point, is significant. So you have two significant figures there. And if it's in the coefficient of scientific notation, it is significant. Okay, so it is two significant figures. A number is not significant if it's just holding a decimal place. For example, this number right here, the 4 is the only significant number in this, because these other zeros are just telling us what place it's in. It's not in the tens place, the hundreds place, the thousands place. It's in the 10,000s place. Okay. A lot of times, if you can look at a number, if you can write it in scientific notation, you can tell how many numbers are going to be significant, because it's whatever that number is times your, or that coefficient times your power of 10. And if the zeros are holding a place, okay, and there's not a decimal point, then they are not significant. And so in this case, only these two numbers would be significant. So that decimal place, it's very important. If there was a decimal place there, all of those would be significant. But since there's not one, then there's not. Okay, I hope that makes sense. All right, so let's try and see if we get these right. So try these, okay, and then we'll see how you do. So go ahead and pause it and then give it a shot. Okay, so hopefully you've done it and you've got the right answer. So we need to look at and see, okay, now these two zeros, are they significant? No, because they are holding a place. What about this one? It is, okay, because it's to the right of that decimal place, and so it's not necessary to hold a place. So this particular number would have two insignificant zeros, one significant zero, and how many overall sig figs would it have? 1, 2, 3, 4 significant figures, right? This number has how many? Is this O significant? 0? Yes, absolutely, because it's between two significant numbers. So this one would have 1, 2, 3, 4, 5 significant figures. What about this number? These zeros are not significant because they're just holding a place and there's no decimal, but this 0 is in between these numbers, okay? So that one would be. So there's 3 that are not, 1 that is, and overall there's 4 significant figures in that number. Hope that's clear. So those are measured numbers. An exact number is a number that you get by counting something, or it's a definition of something. So like 8 cookies is an exact number because you're not measuring them. You don't have, you don't have some question about if is that a cookie or not. Eggs, 6 eggs, okay, that is an exact number. That's something that you counted. If I say there are 4 cups in 1 quart, that is an exact number because I know there are exactly 4 cups in 1 quart. I also know there are 1,000 grams in 1 kilogram. So those are like defined conversions. And so those are also considered to be exact numbers. Okay? So if you can count them or if they're defined, they are exact numbers. If you measure them, they are measured numbers. So let's look at these numbers below and decide if they're measured or exact, and then how many significant figures are in that number if it's measured. All right, so go ahead and try them on your own and then come back. 3 coins, is that exact or is that measured? Well, that is exact, okay, because we counted them. And that has 1 significant figure in it, but it's an exact number, right? So it really doesn't matter. The diameter of a circle, that is measured. That's something that we would measure. And so how many significant figures does that have? 4. That's right, because that 0 is in between 2 other numbers. 60 minutes equals 1 hour. Is that measured or exact? Exact, okay, because that is a definition. Okay, all right, very good. I'll talk to you soon when we do section 1.6.